Hey, Christina, so good to see you. Hello, hello, hello. Wow, look at all these things. Yeah, absolutely. TV, cell phones, um, the TV, air conditioning, electric cars, tablets, lamps, our homes, fridge, chargers, electric cars, laptops. Yeah, yeah, yeah. All those things use electricity. 100%. We are very reliant on absolutely, Ryan, Rylan. Yep, yep. I will do that today. I promise. Okay. We are pretty reliant on electricity, right? Uh, so many things that we use and depend on a daily basis really revolve around electricity. And that really lays the ground for work for so many of our needs and resources that we need to use, right? So, as always, class norms and expectations. Please don't share any personal information. Remember to keep your behavior, language, and webcam school appropriate at all times. I dearly appreciate your participation and engagement in class. And last but not least, don't forget Class Connect sessions will be recorded and distributed for learning purposes. Pacifico, hello, hello. So glad you're here. So today we are starting Unit 5, which is all about electricity and magnetism. So when we combine that, it is electromagnetism. Okay. And this unit, you'll see here in just a minute, is fairly short because we only have 13 days left of our trimester, which is kind of a mind blower. And don't forget that this Thursday, that Unit 4 exam is going to be due. Okay. So this is Unit 5. You can see that there's 5 lessons, right? And we will have an exam at the end of this unit, but it's going to be one that we do in class. So a little bit different than the exams that we've done previously. Okay. So I just dropped your notes in the chat box. Okay. Our objectives by the end of today, we should be able to define electricity, define magnetism, predict how two magnetic poles will interact, and predict how electrical charges will interact. So give me a thumbs up. Let me know you have those notes and you are ready to go. Awesome, awesome. Thank you, Angelica and Brittany, Sierra, Jalea. Thank you, Christian and Errol and Grace and Gwen, Pacifico, Jenna, Kaylee. Thank you, Kura and Michelle. Thank you, Sabrina. Awesome. Fabulous. Okay, so let's do this. Okay. So, what happens when you bring two magnets close together? Drop in the chat box. What happens when you bring two magnets close together? They stick together. Yeah, yeah, yeah. Do they always stick together? They connect, but they have to have opposites. Yeah, yeah, yeah. Good. Hey, DC, I'm so glad to see you. Exactly right, guys. They can repel or they can attract, right? Uh, exactly. And it depends on their orientation, right? Because as Jalea said, they have to be opposites. Yeah. So I think probably today there's going to be a lot of what we're doing today. Uh, you might already know, and that's fine. Okay. It'll be kind of a repeat. So, question number 2. As we talk about electromagnetism, we need to know a little bit about atoms, okay? Even though chemistry is next trimester for most of you, okay? All matter is made up of atoms. Atoms are the smallest complete unit of mass. However, they also have different parts, okay? The nucleus of an atom is in the middle, and you can see the red and green balls in the image on the lower left-hand corner. That's the nucleus. It's composed of protons, which are positive. Those are the red balls with the plus sign in the middle. And then the green ones are neutrons, and neutrons are neutral. They don't have a charge. Each proton and neutron have the mass of one AMU. AMU stands for atomic mass unit. Now, that doesn't tell me a lot, okay? AMUs, but when you take chemistry, you'll start learning about atomic masses. Anyways, so they take the protons and the neutrons make up the most mass of the atom. Then we also have electrons that orbit the nucleus. Those are negatively charged, but their mass is so small we really don't count them at all. Okay, looks like we've got about 16 people. Okay. Thank you, Joseph, Tatiana, Sabrina, Ryan, Rylan, Becky. Thank you, thank you, thank you. Thank you, Kira. Najina, thank you. Go ahead and click on the A if you would. That would be fabulous. Thank you, Michelle. You too. Okay, thank you, Maddie. Thank you, Kylie. Thank you, Jenna and Pacifico, Quinn, Grace, Errol, Emily R, Emily L. Thank you, thank you, thank you. Thank you, Sierra and Christina, Brittany, and Angelica. You guys are amazing. Okay, so electricity is a flow of charges, okay? And as some of you have already said, opposites attract, right? So a great example of this is when we see lightning strikes, okay? Particles in the cloud build up electrical charges. Typically, in a cloud, we have the positives at the top of the cloud, and then negatives build up on the bottom of the cloud. And on Earth, those positive charges kind of come up to the surface on ground level. And then when enough charges build up, those charges are released and they rush towards each other. And that's when you get lightning and thunder. Okay. Thank you, Angelica. Thank you, Antoine. Hello. So glad you're here. Thank you, Brittany and Christina, Sierra, Jalea. Thank you, DC, Errol and Grace, Gwen, Pacifico, Jenna, Kylie, Kira, Maddie, Becky, Ryan, Rylan, Sabrina, Tatiana, and Joseph. You guys are amazing. Okay, so let's watch this little clip of how charges build up in a cloud and then they discharge when enough charges build up. Can you see how on the bottom of the cloud those negative charges are building up, and then they are attracted to those positives, the positive charge on the earth, right? And that's what releases that charge. And then we see the lightning and we hear the thunder. Okay. So that is very different than what happens with static electricity. Static electricity is those charges are built up, particularly due to friction. If we continue rubbing, materials will build up a charge, a negative charge on objects. And then there's an attraction between the positive and the negative charges. But these charges don't move. Okay, so that's the difference between like lightning discharge and then static electricity, whereas there's just an attraction between two objects. Okay, so this is question number 4. Question number 4 is net. Okay. Thank you, Joseph and Tatiana, Sabrina, Rylan. Thank you, thank you, thank you. Maddie and Kira, thank you. DC, Emily L, Errol, Grace, Gwen, Pacifico. Thank you, Angelica. Thank you, Antoine, Brittany, Christina, Sierra, Talia. Thank you, thank you, thank you. You guys are amazing. Perfect. Thank you, Emily R. Perfect. Najina, you good? Yeah. Okay. So again, I have a clip of static electricity. And this is balloon. Okay. And you can see they rub that cloth on the balloon, which builds up the charge. And then look at what's happening to the water. Okay. Instead of the water dripping straight down, the water is actually being attracted to the balloon because of that static electricity. So there is no discharge, no changing of charges, but there is a attractive force that's being applied to the water. Okay. Okay. So that's static electricity. Now it is your turn. Take the terms on your left, the vocabulary terms on your left, and match it with the definitions found on the right. Yep. The nucleus is made up of protons and neutrons. Protons are positive, neutrons are neutral. Electricity is that flow or movement of electrical charge. Static electricity is when a material has a net overall charge, but they don't. And then finally, we've got electrons, those negative charges that orbit the nucleus of an atom. Perfect. So that is question number 5. Question number 5. Angelica, that's awesome. That's weird, DC. I see you and you're in my galley. So I think you're fine. I would just ignore that. That's probably just some sort of glitch, but I've got you. Are you talking about attendance? Did you get a robocall? Is that what you're asking? Oh, gotcha. So with attendance, we're supposed to take that attendance within the first 5 minutes. And if you're not on my galley, I have to mark you absent on that robocall thing. Know that it doesn't matter, other than it's annoying getting a robocall, but it doesn't reflect on your grade at all. Okay. Yeah. Okay. Looks like everybody is done with question 5. Awesome. Perfect. Now, when we look at hey, Jennifer. Okay. Thank you, Jennifer. Thank you, thank you, thank you. I appreciate you. So magnetism is a force, right, that can attract or pull, or it can do the opposite. It can repel or push away, right? You're done with the notes, Grace. Amazing. Yeah, I'll review for you, right? Um, because they contain a magnetic material. So a magnet has a north pole and a south pole. Okay. Um, and the north pole points to the Earth's geographic north, and the south pole points towards the Earth's geographic south pole. Okay. So I'm going to show you again a compass and a magnet. Now I'm going to pause this for just a second. Um, right here. Okay, yeah. And you can see that the magnet, the red side of the magnet is S for south. And so the white tip of the compass is also the south pole of the compass. And you can see how they are attracted to each other, right? Now, when he takes the magnet and flips it, so it's the north side of the magnet, okay, then the red side of the compass is attracted to it. Now, when you lay that magnet horizontally, you can see it really wigs out the compass, and the compass doesn't know what to do. It doesn't know whether to go to the north or the south side. Okay, so I think we are done with question 6, right? So in the chat box, tell me if the north pole of the magnet is attracted to the Earth's geographic north, then that's actually the Earth's magnetic what pole? North or south? Okay, magnetic south. Angelica, Brittany, Sierra. Yes, exactly. It's actually the magnetic south. If the magnet is attracted to it, then it's going to be the south, right? So we have the magnet and then the geographic north and south pole. And you can see how these magnetic fields line up, right? Okay, now here, okay, we've got magnetic poles, right? Magnetic poles. If I have two norths, those are opposite, and they are going to, those are not opposite. Hang on. Those are likes, okay? Those are likes, and they are going to repel each other. If I have a north and a south, that is opposite, and they are going to attract, right? If I have two souths, those are likes and they will repel. So that's a magnetic pole. What happens with electric charges? Okay. Electric charges follow the same concepts. Likes repel, opposites attract. So this time I want you to take your annotation tools and complete this chart for me. Positive and negative in that first row. Is that a like or opposites? And remember, this is an electrical charge. Yeah. Excellent. They're opposites. Good job. So are they going to attract or repel? Yes. Perfect. Positive and positives are likes. Negatives and negatives are likes. So they're both going to repel. Perfect. Yes. So magnetic fields and electrical charges work the same way. Okay. They work the same way, which brings me to questions 7 and 8. Okay. And this you're going to complete on your own. Okay. Complete on your own. If you want to confirm it, you can in the private chat. Okay. So Jalea, yes, your question to 7 is correct. Okay. Sierra, yes. Jalea, yes. Antoine, 6, I don't know what 6 is. Class, you're going to have to tell Antoine if he's correct or not. Sierra, yes. Jennifer, no. Okay, there are 2 positives. Pacifico, yes. Angelica, yes. So, Brittany, yes. Gwen, okay. And anybody else that's unsure about question 8, Emily R, correct. The South Pole, okay, is pointing towards the geographic Earth's south. But what is it going to be attracted to? Is it going to be attracted to the magnetic north, south, negative or positive? Angelica, correct. Antoine, correct. Okay. Emily R, no. Gwen, yes. Christina, no. Jennifer, yes. Joseph, you were right. Emily R, yes. Antoine, yes. Christina, yes. Michelle, yes. Joseph, I'm not sure what MB is. Jennifer, yes. Michelle, yes. Okay. Christina, no. Think about what the on a magnet, what is the south? What would it be attracted to? Okay. Okay, we have 20 people finished with question 7 and 8. So, how you feeling? You feeling okay? You feeling good? Okay. If you are good, Christina, no. Try again and let me know what you think. Okay. If you are still confused or want some help, hang back. We will work through it. Okay. Otherwise, you can submit and you can, Christina, yes, you got it this time. Hang back and we will work on things together. Okay. Bye, Rylan. Bye, Antoine, Sierra. Bye, Maddie. Bye, Michelle. Talia, you have a great day. Bye, Pacifico. Bye, Brittany. Bye, Joseph. Bye, Angelica. Bye, Sabrina. Have a great day. Bye.